Let's try a quick riddle. How many legs does the animal that spins webs have? You probably answered 8. But notice something about the sentence you just read. The word spider was never actually spoken. To solve the puzzle, you retrieved the concept of a spider, held it briefly, and used it to find the number 8. Language models are often described much more simply. They predict the next token from a probability distribution. But that output is produced by many layers of internal computation. Researchers have now identified a sparse family of internal representations they call J-space. These representations are poised for verbal report and support several tested functions. But J-space is incomplete. Only a small, report-relevant part of model activity. Most activation variance remains outside this interface. In tested layers, it never exceeded 10% of activation variance, with typically no more than 25 active directions. They measured these directions with a tool called the Jacobian lens, or J-lens. It estimates how a small change to an intermediate activation would affect present and future output tokens, averaged across many contexts. In the web-spinning animal riddle, the lens surfaced a spider-associated representation, even though spider appeared in neither the prompt nor the answer. Then, the researchers tested whether that internal signal mattered. They exchanged the spider and ant lens coordinates. The top output changed from 8 to 6, while the component orthogonal to those two directions was left unchanged. That is causal evidence for this intervention. The tested internal representation influenced the tested result. It is not a complete map of the model's reasoning. The paper also asks whether one representation can be reused by different downstream operations. In one example, the shared argument was France. Separate prompts asked for properties such as its capital, language, and continent. The researchers applied the same internal swap, replacing the France lens vector with China across a band of intermediate layers. In the illustrated example, the downstream answers changed to the China-appropriate results. Across the larger benchmark, however, the intervention worked on some trials, not all of them. One patch influenced several related outputs in this test, not an entire worldview. The result is consistent with a broadcast-like representation that multiple downstream circuits can read. The lens also surfaced report relevant internal features in other examples, including a bug in code the model was asked to inspect. In one prompt injection case, the readout surfaced fake, injection, fraud, and poison before output. Output alone would not reveal all of those intermediate signals. Specific audits surfaced signals such as manipulation or secrecy. In two specially trained misaligned models, some signals tracked hidden objectives, not generic AI intentions. J-space does not make AI transparent or trustworthy. It is a limited tool for observing and testing some report relevant representations before output.